The solubility of the sparing soluble salts depends on the equilibrium of the ionization. However, the equilibrium may shift the solubility, then changes. There are many factors can affect the solubility of the salts. Here are some of them: pH effects, complexing agents, common ions, and others. If the anions of the salt is of base in nature, it's reactive to acid. Then the salt is more soluble in an acidic solution. If the cations in the salt interact with the complexing molecules strongly, form complex ions, then the salt is more soluble. And if there's common ions in the solution, the equilibrium of the dissolution shifts back to form salts. The solubility of the salts decreases. The equilibrium shift can be described by the Chatelier's principle perfectly. It states that when a system at equilibrium is disturbed, there is a net reaction in the directions that partially counteracts the disturbance. Let's see an example and explain it with this principle. In the dissolution, ionization of silver bromide ionizes to give silver ion and bromide ion. If ammonia is added in too, silver ion will react with ammonia to form complex ion. The equilibrium constant of this reaction is as high as 16 million, which means all the silver ions will be consumed if ammonia is excess. If no or less silver ion in the ionization of silver bromide, QSP of the dissolution is less than KSP. Then the equilibrium shifts right. More silver bromides dissolve and more silver ions are released to reach a new equilibrium. Another example, the dissolution equilibrium of calcium sulfate. The salt gives calcium ion and sulfate ion. If proton is introduced into solution, will it change the equilibrium by forming hydrogen sulfate ion? The equilibrium shifts to the right or not?
Let's answer the question by calculation. Here is an example. Question: evaluate if the following reactions will promote the dissolution of calcium sulfate. We first reverse the chemical equation of hydrogen sulfate ion. Kb for protonation is Kw divided by the given Ka, 9.1 times 10 to minus 13. Then we add this equation to the other two. We can get the chemical equation of acetic acid reacts with calcium sulfate. The equilibrium constant of this equation will be the product of the equilibrium constants of these three equations. And we finally have the equilibrium constant for the overall reaction, which is 1.49 times 10 to minus 22. It's too small for a reaction. We can safely conclude that the acetic acid cannot promote the dissolution of calcium sulfate. One more question about a common ion effect. Question: what is the concentration of silver ion in a solution of 0.2 moles per liter sodium chloride with solid silver chloride? If X is assumed as the concentration of the silver ion, the concentration of chloride ion at equilibrium will be 0.2 plus X. Ksp of the silver chloride in the solution equals X times 0.2 plus X. For simplicity, X in the term of 0.2 plus X is neglected. Then we have X, the solubility of the silver chloride is 9.0 times 10 to minus 10, very low. The chloride ion from the sodium chloride suppresses the dissolution of silver chloride.